question. Actually, I have put the source of this question yesterday, and I will just in the usual way, whatever the source which I am putting over, okay, I'm just explaining it. Okay, so this trend we are going to follow again. Okay, yeah. So I think this question is visible to you, right? Yeah. So here, what we did, a two parallel lines are given. Two parallel lines are given, AB and CD. Here you can see the two parallel lines AB and CD. Now, the AB and CD are two parallel lines, and this is the figure where this angle is given as 108, that means angle EAB, and angle ECD is given at 112. We need to find this angle X. Okay, now how we will be doing it, let us see. I will be putting some extra paper over here so that it will be explained to you. Okay, here it's given that this is a line, this is a line, these lines are parallel to each other. This line is AB and CD, and this is connected like this, right? We need to find the value of this angle X. We need to find the value of this angle X. If this is given as 108 degree and another angle, this one 112 degree, right? Let's say this is a point P. Now in such questions, since AB is parallel to CD, this is CD, it's given that AB, this line is parallel to CD. Now we need to find the value of X is what? Here, draw a line from P which is parallel to AB and CD like this. So here we can say do construction AB parallel to CD. This is already there. Now what we did, we constructed PE. So all these three lines are parallel to each other, right? Now this is 108 degree. Now break this X angle into two parts. Let's say this is angle 1 and this is angle 2. If this is angle 1 and this is angle 2, we can say that X equal to 1 plus 2. X is 1 plus 2. X is 1 plus 2, and we find the value of X. And we know that when two lines are parallel, so AB and PE are parallel, so we can say that angle 108 plus angle 1 will be 180 degree. So I am writing it, 108 degree plus angle 1 is 180 degree. So here we are calculating the value of angle 1 as 180 degree minus 108. So it is coming as 72 degree. So angle 1 is known to us as now 72 degree. So this is 72 degree. This is 72 degree. Right? Now similarly calculate angle 2. Since PE is parallel to CD, just to refer this, right? Since PE is parallel to CD, similarly we can say that angle 2 plus 112 degree is equal to 180 degree. Why? Because these are co-interior angles between two parallel lines. PC is the transversal, you can see this is the transversal, and these are two parallel lines, right? So this is cutting like this. So angle 2 plus 112 is equal to 180 degree. So angle 2 can be calculated very easily as 180 minus 112. So this will be coming as 100 minus 100, it will be 0. 80 minus 12, it's coming as 68. 68 degree, right? So 68 degree is the value of angle 2. So this value is known as angle 2 is calculated as 68 degree, right? Now this is 68 degree. Now what is the value of x? What is the value of x? X is 1 plus 2. X equal to 1 plus 2. Here you can see. So x is 72, right? And y is 68. Just add up to get this value, this one. So angle x is calculated as 72 plus 68, that is 8 plus 2, 10, carry 1, 14. So 140 degree. So 140 degree is the answer which you have derived for this x. So x equal to 140 degree is our answer. I think it's visible, right? So in this question, how to search such question of lines and angles I have explained, right? Now this is the shorts which already I put into my channel yesterday. Now I will explain you some different question. Okay, so let us come to is there any query, students? Because I'm little bit fast over today. Is there any query? You can put up into the comment box. I will just referring the chat in between. Thank you so much for watching. Yeah, so coming on to the next work, that is next question. So yeah, so here I have taken a question where a cloud is given, where a cloud, this is a question of trigonometry, okay, where a cloud is given like this, okay. If this is the cloud, oh no, yeah, if this is the cloud, and cloud is, if the angle of elevation of a cloud from point h meter above a lake, and here is a lake, and angle of elevation, so let us consider it as a straight line, right? So if this is a lake, right, then angle of elevation from a point h meter above the ground, so let us say this point is h meter above the ground, right? From here you are just putting an angle of elevation of here. It's given that if the angle of elevation of a cloud from a point h meter above a lake is a, right? So this is given as, this angle is a, that means alpha. If this angle is alpha, right, and the reflection of this cloud, so if this is h, suppose cloud is at this much distance from the lake, okay, same distance it will be covered below under the water, and the image will be seen over here, right? So that distance will be coming as, if this is h, this will also be h. So let us name a, o, b, c, d, and the reflection, if the height of the, if the cloud is h plus, let us say x, h plus x, if this is x, and this distance from here to here, what will it be? This is h and this is x, this will be h plus x, right? H plus x. So the image of this cloud in the water will be also at the same distance here, right? This will be h plus x, right? And the angle of depression from the same position to this image of this cloud is given as beta. So this will be coming as like this, right? Angle of depression, that means when you are looking downward, so from the horizontal, this angle is given as beta, right? And we need to prove that the distance of the cloud from the point of observation is 2h sec alpha by tan beta minus tan alpha. So this we need to prove. That is the distance of the cloud from the point of observation. So this is the distance. This is dotted line, right? You can see directly. So let's say this is y. AO is equal to y. So I'm not explaining these things over here. Just refer the diagram. AO is equal to y and considered BO is equal to x. And the distance of the cloud from the lake surface is h plus x. So I have written it over here, right? You can see here h plus x here, right? And the image of this cloud under the water will be at the same distance, whatever the distance of the cloud from the surface of the lake. If this is h plus x, then the image of the cloud is also at the distance of h plus x, right? So this is h plus x. And the angle of elevation is alpha for the cloud and angle of depression is beta for the image of the cloud. Then we need to prove that the distance of the cloud from the point of observation from A to O is this one. So this we need to prove, that is y equal to this much, right? Y equal to this much. Now we know that these two angles are given and this h is given. This is the only three data which is given to us. Now consider this triangle ABO. Here you can see AB is the distance. AB is the distance or separation from the point of observation to the vertical line which is forming. So here AB is the distance. Similarly, DC is also the same distance. So consider the triangle AOB. In triangle AOB or ABO, because you are putting the at center the right angle, this one. This is 90 degree. So you are considering this triangle, right? So in triangle ABO, the relation between AB and OB, let's say this distance is D, then DC is also equal to D, right? In triangle ABO, we can write tan of alpha, this one is the relation of this perpendicular and base. So what is perpendicular? That is x, that is B to O, divided by this one D. Why we are deriving it? I will explain it. Because D is the common thing which is lying into both these triangles. And we will substitute the value of D with the rest of the thing so that D can be eliminated and we have a variable in form of x, right? So two equations, two variables. So D will be eliminated and we'll get the value of x. When you get the value of x, by using the sign component, you can calculate the value of y, which is the distance from the point of observation to the cloud, right? So tan alpha equal to x by D, or we can say D is equal to x by tan alpha, isn't it? Right? So this is one of the relation we have derived. Now similarly, go to the second triangle. I'm just changing the pen color, pen of the color of the pen, so that you can understand. So going to the second triangle, triangle AB. Oh, I'm not given any name over here. Let's say it's a E. E. So considering this triangle now, where the angle of depression is given, right? Now in triangle ABE, what is the relation? Tan of beta, because in tan beta you are getting the relation with this D, right? So we can write tan of beta equal to perpendicular by base, because you are looking from this side and this is the angle of depression, so perpendicular will be B to E. So BE will be coming into the top. And what is the length of BE? That is, we will just bifurcate it into the next step, right? And AB, BE by AB, and AB is what? It's D. See here. Here we have derived in D relation with the relation of the derivative. We have derived the values of D in the above equation, and here also we are going to derive D, right? So we can write D as BE by tan B. And what is BE? BE is BC. This is B. This is C. BC. This is BC. Right? BC plus CE. BC plus CE divided by what? D is going to the LHS, so tan beta will be coming to the denominator of RHS. So here you can see D equal to X by tan alpha and D equal to BC plus CE by tan beta, right? So if this is equation number 1 and this is equation number 2, so we can write by 1 and 2, what? We can write value of D. We just equate the value of D. X by tan alpha equal to BC plus CE. What is BC? BC is H plus CE. What is the value of CE? CE is H plus X, because that is the distance, that is the image distance from the surface of the leg, that is under the leg. So it will be H plus X. This is CE, right? Divided by tan beta. So what is tan beta? Yeah, it's, we can derive into the form of tan, because this is the requirement which we need to prove. This one, right? Here you can see this equation is into the variable, only one variable is here, X. So just replace the value of X to get it. Okay, so just solve it. So tan beta will be multiplying this side, so we are getting X times tan beta is equal to tan alpha will be multiplying this side. So H plus H will be 2H. So I am directly writing over here 2H. 2H into tan alpha, right? Plus X times tan alpha, right? Now bring X terms together. Bring X terms together. So here we'll be having X times tan beta minus tan alpha. See students, here we are going to derive the actual requirement which we need to prove, the distance, because tan beta minus tan alpha, here it's coming into the denominator. So we are just close to that, equal to 2H tan alpha, this one, right? And from this we get X as 2H tan alpha divided by tan beta minus tan alpha, right? But we need to prove, or we need to find the distance AO. AO. Now think, we know the value of X now, that is already derived, right? We know the value of X, we know the value of tan alpha, that is the same, that is given. Then relation of Y and X can be calculated. What's that? The relation of Y and X is given by perpendicular and height, hypotenuse. What is that? Yes, that is sine, right? So just quickly, directly deriving the answer now. Sine, take the sine component. So sine of alpha can be written as X by Y, right? Y is the same thing which we are going to derive, that is the distance of the cloud from the point of observation. So this is Y. So we are from here, we are getting y as x by sine alpha, right? X by sine alpha, isn't it? So x by sine alpha. So what is sine alpha? Keep it as it is and put the value of x over here so that you will get this answer directly, right? So y can be written as I'm just putting it over here little, yeah, y equal to x by sine alpha. What is the value of x? This is 2 times h tan alpha divided by tan beta minus tan alpha, right? That we have already derived here. And when this will be divided by this sine alpha, we can say 1 by sine alpha over here. So you can say tan alpha can be broken as sine alpha by cos alpha, and that sine alpha will cancel out this sine alpha into the numerator, into the denominator, and we have left with into the numerator 1 by cos alpha. So we can say that, so let me break it so that it will not. So tan alpha by sine alpha. What is tan alpha by sine alpha? See, tan alpha by sine alpha. What is it? See this. This is tan alpha and this is sine alpha. So tan alpha by sine alpha will be coming as sine alpha by cos alpha divided by sine alpha. So here you can see sine alpha will be cancelled out and we are left with 1 by cos alpha, and 1 by cos alpha is sec alpha. You can see sec alpha here, which we are going to derive. Now we can write it as y equal to 2h, this one 2h sec alpha, right, divided by tan beta minus tan alpha. So this is the value of y. What is y? Y is the distance of the cloud. This cloud. Y is the distance of this cloud. Y is the distance of this cloud, right? From the point of observation which is h meter above the lake, right? So we have derived y as this one 2h sec alpha by tan beta minus tan alpha. I hope you followed the steps. So here we have derived it, right? So this is the cloud distance. I am writing it. This is the cloud distance. So any kind of cloud related or any height and distance related questions of trigonometry, you can simply draw the diagram. Okay, here the point of observation was h meter above the lake. Lake will act as a mirror. This lake will act as a mirror over here. So the distance of the cloud above the lake, you know, the image distance is also at the same distance. So here it is. So if the cloud is at h plus x, you can see the image is also at the distance of h plus x. But this h plus x will be added with this h, right? This h will be additional to this h plus x. So this h will be added. So we will be getting 2h plus x, 2h plus x, this one, as the image distance. From when we are considering, we are connecting a direct line from the cloud to the cloud image, then you can see from the surface of the lake, the image will be at a distance of 2h plus x. 2h plus x, right? This is the image distance, right? So I think I have explained this question to you. Yeah. I'm just adjusting a little. Thank you so much for your patience, students. Yes. So I'm just coming up with the next source now. So this I have explained to you. Okay. This question of height and distance, which source I put into my channel. This question I have explained to you. Okay, how to calculate it. Now coming on to the next question now. Let me take one more paper because it's already filled. We consider this question and this is also done. Now let me take some more. Yes, I will just explain. This is question of physics. Okay, what was the question? Let me show you. That a suspended wire is suspended from a ceiling like this, and whose, let us, I'm drawing this wire like a cylinder, because the area of cross section of this wire is given. This was given, right? What's that? The area of cross section of this wire is given, and a weight is suspended over here. A weight is suspended over here like this. A weight is suspended here, and the mass of this, not, I'm just mark my words, it's mass, not weight. Okay, it will be, we will consider the weight of this mass, but here it's given as m equal to 4.8 kg. Due to this weight, this wire will be elongated. Students, due to this weight, this, there will be a stress into this wire, right? And this is getting elongated, right? So how much elongation will be there? That we need to find. This, in this question, how much elongation will be there, that we need to find. When it's given that the Young's modulus of this wire is given. Okay, Young's modulus of this wire is given. So I am just reading the question immediately over here. Okay, so what's that? Let me show you. Here the Young's modulus, this is Young's modulus, is given. It's given, and this mass is having a mass is of 4.8 kg. So due to this mass, there will be a tension into this wire. Let's say T, right? Due to this mass, there will be a tension into this string. Now, if there will be a tension into this string, and we have been provided with area of cross section of this wire, now what we will do? Just apply the Young's modulus formula. You know that y equal to stress by strain. Stress by strain, right? What is stress? Stress is the force applicable per unit area. Force applicable per unit area. So that force is this tension. That force is this tension. This area is given to us. Also the initial length of the wire is given. Okay, initial length of the wire is given. What's that? Should I read it? Yes, it's 2 meter. Initial length of the wire is given as 2 meter. Now, what we will do? Stress by strain. Stress will be equal to T by A, right? And strain will be equal to delta L by L, where L is given as 2 meter and delta L is the elongation. That means, suppose due to this weight, this wire is extended till this point. Okay, this wire is extended till this point, and this mass shifted to this position. This mass shifted to this position. Then this is the delta L. That is the movement, that is the elongation of this wire. Sorry. So if this wire is elongated by delta L, then T is known to us. T is equal to T will be equal to M into G, isn't it? Because if you consider wire, or just drawing the free body diagram of this mass, if this is the mass of 4.8, then the weight of this mass will be 4.8 into G, right? And this will be compensated by upward force, which is T. So you can see this is the free body diagram of mass. So from here, just equating the forces, we get T equal to how much? We get T equal to 4.8 into G. Let's take the value of G as 10. Into the shorts, I have written the question and explanations. Okay. So 4.8 will be coming as 48. So 48 Newton is the tension which is developed into this wire due to the weight of 4.8 kg. This is the weight of 4.8 kg. So this will elongate the given wire, right? Now we know the value of T. We calculated the value of T as 48 Newton here. Now, stress by strain. So, why? The Young's modulus is always given into that question, into your question. That need not to remember. Okay, Young's modulus of the steel wire. Here the wire is of steel. So, that data is known to us. So, you can put up the value of Y over here. Okay. Now, T is 48. So, 48 is there. Divided by A, area of the cross section, that's also given into the question. What's that? That area of cross section is 0.2 centimeter square, right? Students, why I am putting the data now? Okay, you can refer the source. Okay, I'm not writing the question because that will occupy the page. So the things which I'm just reading the numerical again. One end of a wire 2 meter long and 0.2 centimeter square in cross section is fixed in a ceiling and a load of 4.8 kg. Load of 4.8 kg is attached to the free end. Why this is free end? Because this end is attached to the ceiling. And find the extension of the wire is given that the Young's modulus of steel wire is given as, the value of Y is given as, I'm writing here, Y is given as 2 into 10 power 11 Newton per meter square. So this value of Young's modulus is given, right? Now we have been provided with three data. What? The length, initial length of the wire, steel wire 2 meter. Area of cross section. What is the area of cross section? Students, this is the area of cross section. When you are just taking the top view of this wire, suppose you just seeing from this end, then what you will be observing? This cross section will be observed. It will be looking like a circle, like this. Okay, and this area of cross section is given as 0.2 centimeter square, right? So Y equal to stress by strain, and stress is T. We have calculated the, after drawing the free body diagram of the mass, we have calculated the value of T as 4.8 into 10, that is 48 Newton. So put up the value. In place of T, 48. In place of A, 0.2 centimeter square. So 0.2 into centimeter. Centimeter, just convert it into meter. Okay. This is 1 into 10 power minus 2 meter. And this will be squared. So this will be into the numerator, and into the denominator we have delta L by L. So delta L is the this much, the elongation. You can see from here to here. Due to this weight, this wire extended, right? Due to the weight of this mass, this wire extended. How much? By delta L. So we need to calculate this delta L. So this will be acting as a variable over here into our numerical, and this is divided by L. L is the original length of the steel wire. What is that? That is given as 2. Right. And this is the unit of this 2 is in meter. So leave it as it is, 2 meter. Right. So what we are getting, and then put up the value of y. Young's modulus is given as 2 into 10 to the power 11. So just putting up the value 2 into 10 to the power 11, that is Young's modulus value, is equal to 48. 2 will be going to upward. 48 into 2 divided by 0.2 into 10 power minus 4, because minus 2 will be squared, centimeter square, right? So we are left with, and delta L is also there. So delta L will be multiplied with this. You can know, you can see the here. A by B divided by C by D. Then A and D will be multiplied and B and C will be multiplied. So delta L will be here. I am writing it into a different color because this is our variable which need to be calculated. Right? Now, just do the calculations. That's it. So bring delta L to the LHS. So we get delta L, that is this elongation of this wire, as 48 into 2 by 0.2. So just replace this decimal. So this will be 10 to the power minus 5. Right? So 2 into 10 power minus 5. And this 2 into 10, 11 is coming into the denominator. So Young's modulus value 2 into 10 power 11 is coming over here. So delta L is the this elongation in meter. Mind it, this is in meter, right? Now do this simple calculation. 2 and 2 will be cancelled out, right? 2 and 2 will be cancelled out, and we are left with 48 by 2. 48 by 2, 10 power 11 minus 5 will be 6. So 48 by 2, 48 by this 2. Yeah, let me check the values again. Young's modulus stress by strain, stress is calculated 48 Newton. Area of cross section is given as 0.2 centimeter square. Put up the value over here. Delta L is this is 2 meter. That's fine. So this will be coming as 48 by 2 into 10 power 11 minus 5 will be 6. So when it will be going upward, it will 10 to 10 to power minus 6 meter. So just calculate this value to get 24 into 10 power. So as per the standard format, I am putting it as 2.4 into 10 power minus 7 meter. Right? This is the elongation of this wire. This is the elongation in the steel wire. This is the elongation in the steel wire due to the, this is the elongation in the steel wire due to the this 4.8 kg weight. Right? I hope you understand this question. So this question is very simple. This question is very simple. The Young's modulus is given. Young's modulus is given. This data is given. Area of cross section of the given wire is also known to us. Area of the cross section is also given. Now what we need to do? We need to calculate this delta L, that is the elongation into this wire due to this 4.8 kg weight. So we drawn the free body diagram of this weight, this mass. So 4.2 kg is the mass, then weight will be 4.8 into g, weight equal to m into g. So this will be acting downward, so T equal to mg. So since stress by strain is the Young's modulus, putting the value of Young's modulus as 2 into 10 to the power 11 over here into the LHS, which is this one, and into the RHS, this will be stress by strain. So since T equal to 4.8 into G, that is 48 Newton. So putting the value of 48 in place of stress, that is T. divided by A, stress divided by A, that is 48 will be divided by area of cross section, that is 0.2 into 10 to the power minus 2 whole square, that is 0.2 centimeter square. Just convert into meter. So that's why I've just put in place of 1 centimeter 1 into 10 to the power 10 to the power minus 2 meter and square it. So this will be converted into meter. So this will be coming as 0.2 into 10 to the power minus 4. You can see here, right? Do the simple calculation, put up the value of Young's modulus, Y, put up the value of stress as that is T by A. T is calculated 48 Newton, put it. A is known to us, 0.2 into this is given into the question. Now by delta L by L, and delta L is the variable which we are going to calculate. So just solve it to get the value of delta L as 2.4 into 10 to the power minus 7 meter, right? So this question is solved, students, right? Now do one thing. I am coming to a separate question, a separate sorts. Uh, I've explained you. Uh, the cloud question is covered. Yeah. One more question is there. That is from mensuration. So I'm just changing the seat over here. We have explained this question. Okay. I've explained this question. I've explained this question of height and distance. Once from this was from Young's modulus concept, stress by strain. That is we have covered as per our sorts. Explained it. Height and distance, cloud distance, explained it. Lines and angles, I have explained it today. Now taking a new page over here, and now I am going to explain a question of mensuration whose whose uh, whose sorts I have already put yesterday, right? Now this is a question where the question is given that a, let me read it out. Okay. Given that 1 cubic centimeter of marble weight 0.25 kg, a marble is there whose weight for 1 centimeter cube, what is that? That is marble. Marble. You know, marble which is put into the floor, right? So marbles 1 centimeter cube weight is given as what? 0.25 kg, right? 0.25 kg. So this is marble. I'm drawing this marble. This is just in the shape of cuboid, if you have seen any marble. Okay. So the standard weight per centimeter cube is given as 0.25 kg. So if you have a close view of that marble, you can see the height is the minimum, right? This is the height and this is the length and this is the breadth, right? Now into this question, given that 1 cubic centimeter weight of the marble is 0.25 kg and a block, the weight of marble block 28 centimeter in width. So this is given as 28 centimeter, right? B equal to 28 centimeter. 28 centimeter in width and 5 centimeter thick. This is 5 cm. That is the height, right? Now we have to calculate the length of the block. So given that 1 cubic centimeter of marble weight 0.25 kg, the weight of marble block is 28 centimeter in for 28 centimeter in width and 5 centimeter thick, the length is what? Right? If it's also given that the 112 kg is the total weight. So total marble Weight is also given as 112 kg, right? Now solve this question. You have to calculate the value of length. And what we will do? Simply, the weight is, you can see 1 centimeter cube weighs 0.25 kg. So you can identify the unit centimeter cube. Centimeter cube is coming when? What is the unit of when the centimeter cube will be coming? That will be coming for volume, right? So calculate the value of this cuboid. This is looking like a cuboid, right? Where we have length, breadth, and height all together, right? So, volume. What is the volume of the cuboid? That will be same the volume of the marble over here. If this is the marble, this is looking like a cuboid, and the volume of this cuboid is L into B into H. So this will be the total volume in centimeter cube, and this will be multiplied by per centimeter cube weight, that is 0.25 kg, right? When you will multiply it by 0.25, this will be giving you the total weight. What's that? 112. Just put it over here, 112 kg. Now put up the value. We have to calculate the value of length, right? So length is variable into breadth. What is breadth? Breadth is 28. And what is height? Height is 5. You can see 28 centimeter, 5 centimeter into 0.25 equal to 112, that is kg, and unit of 0.25 is kg. So here you can just see the units. Kg and kg will be cancelled out, right? 0.25 kg, that is per centimeter cube. This is per centimeter cube. Unit weight is given. So this centimeter cube will be coming into the RHS here. I'm just trying to 1 minute. I'm just bringing into the lens, yeah, centimeter cube. Now these 2 centimeters will be cancelled out by 2 from this. So it is left with 1, right? So in the unit there is only 1 centimeter. That is, only 1 centimeter is left with us after cancelling out the units. Now calculate the value of L. This is a simple arithmetic calculation. That length of this marble, that is 112 divided by this entire 28 into 5 into 0.25, that will go into the denominator of the RHS, that is 28 into 5 into 0.25, and the unit will be centimeter. So length is this much centimeter, right? Now replace this decimal. When you replace this decimal, then 2 zeros will be coming into the numerator, right? Into 100. Now just simply divide it. 28 is coming into the table of 7, and 112 is also coming into the table of 7. 717 and 42, right? So just solve it. 7 4 times 28, 717 42, 7 6 are 42, 1600, right? Now 400, just cut it. 4 41600. So into the numerator we are having 400 divided by 25 into 5. 25 into 5. 25 into 5 centimeter. This is the value of our length, right? From 25, cut this 400. 25, 4, 4, 16 times it's deducted, right? So length is coming as 16 by 5 centimeter is the length of Marble. Length of marble is 16 by 5 centimeter. Students, I have already uploaded the sorts of these questions which I have explained today. You can refer that. 5, 3 times 15, 10 decimal 2. So 3.2 centimeter is the length of the marble which we have laid down. Okay. So thank you students for watching and keep on learning. Happy learning. Bye bye. I will come up in the next channel again. Next live session with explanation of some more sorts. Just like and subscribe to my channel. Okay. So that it will give you a good motivation to me also. But any kind of doubt you can put into the chat. I will take it up. Thank you so much for watching. Bye bye.